It's ongoing.
Oh, yeah, it is. And at the annual Carbon Society, the nanotube meetings, annual ones, NT series, and a number of people in this audience are heavily involved with that. There is a side section that is devoted to just that issue, that meets, just before, usually, precedes. It's called a satellite conference, and deals with that.
Does that answer the question? Do we have any more questions? Yes, I see one there. Would you like to get a microphone?
As a student, I just want to ask a simple question. So how much of the work you have abandoned in your whole research life, or you can give a ratio? Thank you.
A give a what?
Abandoned.
Yeah, you have abandoned.
How many research projects have you given up on?
Too few. Well, I made a fullerene generator that was supposed to have the arc in one chamber and a skimmer and blow the material directly into a chamber to do mass spectroscopy on it, and it was kind of a terrible idea. And I mean, it plugged the nozzle fairly immediately with all the carbon stuff that was produced. And anyway, it didn't turn out very well. So that one went away.
Can I comment on that? I think most of us on this stage have had unsuccessful work, right? One thing I would like to say, unsuccessful work is very important. It's a good thing to be unsuccessful sometime and try to tell your boss it's okay. Because by making mistakes, you learn very many things. And you don't want to have people that you hire and employ and so forth that are unwilling to take risks. Because most of the great discoveries, they don't work the first time. Yeah. So you need a little bit of resources and encouragement to keep going. Wouldn't you say that's
But Mary, you see, where I don't agree with you is that unsuccessful project is a mistake. It's
oh,
not
you maybe weren't. Maybe you're always successful, but I'm not.
No. We all have unsuccessful projects, but those are not mistakes. If you knew from the very beginning which one is going to be successful, it's not science. Science is by definition something which we cannot possibly predict.
Yeah, well,
and it's absolutely normal that only 10% of the projects are successful. The others.
Industrial laboratories, they have a different standard.
They have to pay, yes.
Yeah, because they have to pay, and they have a board that they have to report to.
Yeah, I mean,
University is a little bit more flexible.
We are paid with our time and with a lot of gray hair, but they're paying with their money. I'm not sure which is
no, but
more important.
Your university owns you full time. Even when you sleep.
When Rick Smalley was trying to do the armchair carbon nanotube project, he came up with probably dozens of ideas that varied only in how crazy they were. And he'd have a student put it, go try this. And so the student would go and he'd come back and say, oh, these results are very disappointing. Doesn't seem to be working. We don't seem to be getting heard. And Rick's response was always, oh, we've learned something. We've learned that didn't work. There's no unsuccessful experiment.
Yeah, okay.
I think there are some things that are reported in the literature that turn out to be wrong, and some of us go chasing them. I remember the Carbon Conference 27 years ago here. Somebody gave a talk about BC3, which was a graphite structure material, and it was so simple to make. All you had to do was to take benzene and boron trichloride and pass it through a tube and heat it, and you got BC3. And I had a student and I who chased that material for 2 years and never made it. So, I don't know whether we learned anything from it, but...
That you can't make it, right?
Well,
that was
you
an
can't
important
make it,
one,
yes.
I have a very strong opinion about this topic. When you have a student and you give a hard problem that you don't know how to solve yourself, or you think you don't know how to solve, which is almost all the problems I've ever assigned, I always give what I call a bread and butter experiment. That means if you fail on this, you still have something to show for your time, so you can get a job when you graduate. I think that we have to worry about taking on students and our responsibility to them for their early careers. I don't know if the rest of the people will agree with that, but that's a real, I don't know if you could do that in industry so much, but in the universities, we certainly have to do that, because we can manage that.
I mean, in industry, people tend to be well, nowadays at least, it's much more team-oriented than it used to be, much less an individual academic investigator, but more a team that's sort of working on something that has multiple aspects, so you need people with different expertise. And it's even common that one person will actually work with several teams on different aspects of things. So that, in a way, that provides the function of, if one thing totally goes south, you still, at the end of the year, when you do your annual report, have something to put down that, you know.
But for startup companies, it's maybe more difficult.
Yeah, of course. It depends how many eggs you have and how many baskets, right?
Are you missing the time when there were Bell Labs and Philips Labs and AT&T, so where lots of theorists were employed and doing lots of blue sky research in the companies as well? Are you missing those times when you didn't need to write all those reports at the end of the year?
I'm sorry, did you?
I mean, are you clearly now the research in the companies is not the same as it used to be like 30 years ago. So,
yeah.
do you see that it creates problems for the future of those companies? We've seen huge research labs in Philips and Bell Lab and in IBM just disappearing.
Well, I mean, it's an adaptive organization that, you know, I can modestly say tends to hire smart people. So they find things to do that seem to be promising, and indeed a lot of them work out in surprising ways. I mean, you get scanning tunneling microscopes pop out.
Yeah, I was about to ask, do you see the next STM coming from IBM?
Well, that's a difficult question.
Do we have
As
another
you said,
question
you can't
from the
predict.
audience? Are we going to wander around here a lot?
Oh, one thing.
Yes. Can somebody get a microphone
I'm getting one.
It's coming.
to the gentleman?
Sorry.
Okay, all right, thank you. I just had a question about, there's an emerging view that to be able to answer some more fundamental questions, we really need to combine the experiments we do with some modeling and computational approaches. And there's often a little bit of a disconnect, or a larger disconnect, between the models that exist and the experiments that we can do. So do you have any guidance as to how we can design the right kinds of questions and approaches to really answer some of these questions and bring together modeling experiments? And do you see things like the Materials Genome Initiative as a pathway to really push forward the field of carbon nanomaterials?
Well,
I mean,
nobody else.
Do any of us know anything about the Materials Genome Initiative?
Yeah, I do.
Do you?
Yeah, well, there was a guy, just my building, just one floor up. His name was Gert Sater, and he's the one that was a pioneer in this concept and materials genome. As far as I know, he's the initiator of that name, and he had a large program that was addressing exactly that. I was not a personal collaborator with him because I've always worked with theorists my whole career. My husband was a theorist. He was cyclotron resonance theory, electrons and holes. I think many people know that. And when I don't work with him, I work with a lot of his old friends, and I have a whole series of people around the world that theorists that email makes it really easy for me to deal with them. Why doesn't everybody else do that? I don't know. It's so easy. I try to introduce my students to how I do it, and when they graduate, as experimental students have their theory friends, and the theory students that I graduate, they have their experimental friends.
Yeah.
And it works out pretty well for them.
So people should talk, right?
Yeah.
The modelers
Well,
and the
I don't know,
experimenters should
maybe
talk.
they should put all these people in the same building and have cold weather outside so that they see them all the time. And we have free lunch where we meet these people weekly. In all the departments I have students, I go to their lunches when they invite me. And so I know people in many departments at MIT. I have
Maybe
collaborators from half of them.
Maybe our
Personal
questioner is
question.
asking about computational discovery, because now we see many papers where a new structure is proposed based on computation
Yeah.
alone.
Okay.
It's often something no one knows how to make or can even imagine how one would make. And what do you think the role of computation in materials design and discovery is?
The question is it useful? The answer is yes. Does it give you the material properties and explains you what the possible excitement about this material? Probably not, because you simply cannot possibly calculate all the properties and especially predict them in the real system. So as marking the direction of possible research, of possible search, probably yes. But I don't think it will ever replace the necessity in the experimental work and the experimental search for new materials.
Yeah. I promised a question to a gentleman over there. Has he got the microphone? I think you have.
Yeah, thank you. I think my question was partly answered, but my main question is, we all heard about the need for connection between different fields and the need for fusion of different fields. But the problem is we're getting more focused on very specific fields, and then it's not possible to always attend the talks, communicate. So what is your advice for young scientists and for everyone? What should we focus on, broadening our knowledge and understanding in order to facilitate that, communication so that we can, save time and speed up the whole process? Thank you.
You need to learn how to teach yourself stuff that nobody is around to teach you, so that you could so you can broaden. There may not be a course that is about something you're interested in, so you have to create your own one-person course, or maybe you can get a friend to join you.
I think the only way is to swap several labs and try to learn, educate yourself in different areas, trying to find what you really love. There is absolutely no guarantee that your PhD project will be the love of your time, so of your life. Then you need to do a couple of postdocs in different areas and see whether it will work out better for you.
It seems to me, because I think we're going to have to close this in a few minutes. To me, there are a couple of areas of carbon research that, and it is about carbon. Batteries. What do people up here see as the future for batteries? Are we going to see lithium-sulfur batteries that obviously have carbon in them? Are we what is the future prospect for batteries? And the other aspect that I find interesting that's been mentioned occasionally in this conference is the impact that carbon materials have in medicine. That seems to me to be extremely important. And any comments from?
Well, I thought Jeff Don's talk was very good yesterday.
Yes.
I mean, he mentioned that graphite is preferred on a cost basis, but it's also possible that the cost of nanotubes, for example, will go down. I mean, all of these things scale with the amount, right? If you can make it in large enough amounts, it tends to get cheaper fairly dramatically. So presumably that becomes increasingly a way to push batteries. I mean, one thing about batteries is small increments in performance translate into very valuable advances, right? It's not that you're doubling everything every 2 years like, you know, memory chips or something. I mean, there the increments are much more hard fought. And so it seems quite plausible that you could, say, use nanotubes or something in a clever way to make your batteries more conducting, less lossy, more efficient, whatever. I don't know. But there are obviously people here who are experts on all of that. Probably answer your question better.
And that's answer your question on the medicine as well, because surely nanomedicine is going to happen. We're going to use more and more materials for whatever drug delivery, artificial membranes, artificial organs, but the issue of the cost which exists in battery application doesn't exist in medicine. So there carbon will be only one of many other materials. So it will be on the par with, in competition with all the other nanostructures. And there we have to keep our eyes wide open to not to miss this competition.
I think that the interaction between people on this stage in the medical world would be people like us. I don't mean us in particular, but and there are many of us's in the audience that are not on the stage. I have a big advantage for that. My counterpart, my daughter's in-laws, are very prominent in the medical field, so I have good access to the medical world. And living in Boston, the medical school all comes to MIT for their science because they don't have the Harvard Medical School.
Engineering too.
And engineering, yeah. So we see these people, they're always coming and giving seminars. You go to their seminars, you learn what they're doing. So I have an advantage to keep up with some of the things in medicine. And we have people that have degrees, that's one of the very popular degrees at MIT, is a PhD in any science subject that has something to do with medicine, and a medical MD degree, so you can be a practitioner, and you know, that really promotes a very, I don't know if other countries have that sort of thing, but that's, or other universities have that capability, but it involves science and engineering community in a very good way.
That thing that I mentioned that Jim Tour came up with is the only example I ever heard of where actually elemental carbon is the drug, the actual pharmaceutical. Now, I shouldn't say that, you know, I don't know how many more centuries will pass before they start using that in people, but it certainly seemed like a good idea. That's another problem with medicine, is that there's a long time between coming up with some potential drug and when it, you know, because for good reason, you don't want to put something in people that will harm them.
You need to have mice tests and all of this. There's a certain procedure you have to go through, and that's lengthy.
We do have now a carbon heart valve that is completely. It's been given the all clear by the FDA for no post-anticoagulant treatment being needed and so on. I mean, the advances there have been fantastic. It's been slow, it's been incremental, but it's reached a really great position.
Endo Sensei has some inventions like that.
Carbon could be very important and interesting for medical application. As Professor Peter said, already 1970, the heart valve made by carbon was developed, and more than 2 million people have the carbon-made heart valve. So the very high level of the body acceptability or less blood coagulation with carbon, that could be developed with other application, something like artificial bone or other artificial blood vessel or other device could be possible.
And somebody mentioned in the plenary, and I've been very interested in this because of my wife's problems, graphene coating of hip implants, for example, which carbon is, that seems a really very important aspect of carbon work and research in carbon materials. And yeah, Bob, you want to?
I have one question. We have seen Nobel Prize for fullerene. We have seen Nobel Prize for graphene. And the important discovery of nanotubes. We have a quotation mark. I would like that you make some comments on this possibility.
I think we're stunned.
I have no idea. The only thing I'll say is that for most of us on this stage, it isn't prizes that drives us, it's curiosity. We don't care about prizes.
Thank you.
And I remember Millie saying that to me many, many years ago. Very true.
Before she won all the prizes?
Well, I'm willing to accept the prizes, but I don't look for them.
That would certainly kill your career. I think if you decide you're going to, you have to be very, very smart to actually, you know, I've never been smart, I've been lucky. And so, you know, the people who are very, very smart and say, I'm going to go do something and there's going to be a Nobel Prize in it for me, I say, well, lots of luck. And sometimes, well, sometimes very often they succeed, you know. And I'm awestruck by that because I was lucky. I wasn't smart, I was lucky. Being in the right place at the right time, the right situation. Mm-hmm. So my advice to students is be lucky, but I'm not sure how to implement that.
Well, we were certainly lucky to have this event today. And thank you all for joining our living room conversation. I don't know if the DVD will be available, but I think I had a wonderful time, and I really hope you enjoyed this.